The term inheritance can be used in many different contexts, such as biology, where genetic information is passed down from the parent to the child, and this is why Harry Potter had his mother's eyes. It could also relate to finance, where assets are passed down from generation to generation. But in object-orientated programming, inheritance refers to the properties and methods of different objects being passed down to other objects. So in this video, I'm going to explain why inheritance is useful in object-orientated programming. I'm also going to explain how we can actually implement it within our code. Okay, so I'm going to begin by demonstrating inheritance with a football team. So we're just going to create our own package called com.team, and this is where we're going to store our football team members. So the first class we're going to create is going to be a goalkeeper class. And then this goalkeeper is going to have a few properties. So we can give them a name, which will be a string. We can also give them a height, which will be an integer. We can give them a void method, which is called play. And then within the play method, just for demonstration purposes, we're just going to print out the word playing. Now the team will also consist of other kinds of players, so we might have a defender. So I'm just going to create that defender class. And similar to the goalkeeper, they're going to have a name. We're also going to give them a height of an integer. And then similarly, we're going to give them a void method of play. And then I'm going to do the exact same for a midfielder and also for a forward. So we have all the different positions covered for this team. So as I finish writing the forward class, you may begin to realise that we have a slight problem here. We have repeated the properties and the methods for 4 different classes. So if we were to introduce a new method, such as warm up, we would have to write this method in all 4 classes. This repetition of code is breaching one of the principles of software development known as D.R.Y, which stands for Don't Repeat Yourself. So to resolve this problem, I'm going to create a new class called player, and we're going to use inheritance to get around this problem of repeated code. So the design that we use when we implement inheritance involves creating a parent class which will be holding all the common attributes and methods. So I'm going to name the parent class player, and every time we use the parent class, we are defining a subclass, and we often say that the subclass is a parent class. So for our example, a defender is a player, a midfielder is a player, and so on. So now that I've defined the parent class, I'm just going to create an application class so we can begin demonstrating how inheritance works. So the first thing I'm going to do is create a player, and I'm going to call the play method, and I'm also going to create a goalkeeper and call the goalkeeper's play method, just so that we can see how they work before we make any changes. So in the console we can see that playing is printed twice, first from the player and second from the goalkeeper. What I'm going to do now is allow the goalkeeper to use inheritance upon the player, and we're going to do this by adding extends player beyond the goalkeeper name in the goalkeeper class. The word extends is a keyword within Java which tells the class to inherit the attributes and methods from the class player. So this means all the attributes, so the name, the height, and the play method, are now inherited in the goalkeeper without me having to write them out. So I'm just going to head back into the application class, and we're going to run the main method one more time, and we can see that playing is printed twice to the console, even though we've removed the play method from the goalkeeper class. I'm now going to repeat this process for the defender, the midfielder and the forward class. So I'm going to remove their attributes and methods, and I'm going to have them extend the parent player class. So I'm going to move back into the application class, and I'm going to instantiate a forward class instance. And if we press F dot, we can see the access to the height, the name, and also the play method. And to demonstrate how access modifiers work with inheritance, so I'm now going to create a new class called substitute, and the substitute class is not going to be in the same package as the other classes. So I'm just going to create a new package called com.other, and within this package I'm going to create the substitute class, which also extends the player class. If I head back into the application class and create an instance of the substitute class, I'm just going to call this S, we will now be able to see which attributes and methods the substitute class has inherited from the parent class. So if I press S dot, you can see we don't have access to the name, the height, or the play method, and that's because the default access modifier in the player class doesn't allow the substitute class to actually see it. So what I'm going to do is just make the name, height, and play method public. So now the substitute class should be able to see it, and if we press S dot, we can now see these three attributes at the top. So rather than leaving these attributes and methods as public, which allows them to be seen by all classes in all packages, there is actually an access modifier that fits between default and public, and this is called protected. And what protected means is that any class that extends the parent class is able to see the attributes and the methods regardless of which package it is in. So I'm just going to head into the application class and verify that we can still see the attributes and methods even after they're changed to protected. And one thing I'm going to do now is just backtrack a little bit. So I'm going to remove the extension of the substitute class. And the reason I'm doing this is so we can see how Java classes actually obtain these methods. So we can see equals, we can see hash code, and we can see toString, amongst many others. And these all inherently come from the object class, which is part of Java. So we can actually find the object class if we search for it using double shift in IntelliJ. And what we can see is the hash code of the object class, the equals method of the object class, and also a few others such as clone and also toString. So it's worth having a look at these methods. I think it's quite interesting to understand how our objects obtain some of the methods that we use quite frequently. So I'm now going to begin by taking a look at the constructors and how the subclasses are actually created. So I'm going to move into the player class and I'm going to create just a basic constructor. I will just print out a line to the console. And now I'm going to run the application class just so we can see what is printed to the console. We can see in the console that the player class is actually created 4 times for the 4 classes that we're instantiating. So to provide a little bit more visibility, I'm just going to create the constructor in each of the subclasses so we can see exactly what's going on. So each of these constructors are just going to print out a single line to the console. So we'll have creating a goalkeeper class for the goalkeeper, similarly for the defender, the midfielder, and also the forward, and also the substitute class. Now if I run the application again, we can see more lines printed to the console. So the first one is for the player. Creating a player class and the goalkeeper class is for the goalkeeper, and then so on for the forward and the substitute. So what we actually see is that the player class constructor is called first, followed by the goalkeeper class. So by default, the subclass will be calling the noArgument constructor of the parent class. So I'm just going to add a string into the constructor of the player class, which is the parent. And I'm just going to update the system out print line to show that it's updating the name in this constructor. And we're now going to see that there's a little bit of a problem for all of our subclasses. And the reason we have this problem is because behind the scenes, the subclass is calling the noArgument constructor of the parent class, and as we've changed the noArgument constructor of the parents class into one that takes a string, we're no longer able to call the noArgument constructor of the parent class. So I'm going to write super and then I'm going to pass the name in from the constructor. And what super does is call the parent class constructor. If I were to put super without anything in the brackets, it would call the noArgument constructor of the parent class, which is why I've put in the name that is passed into the constructor. If I also had a noArgument constructor in the parent class, there wouldn't be any problems with these constructors anyway, because by default they would be calling the noArgument constructor. So I'm just going to update all the other constructors to take in a name, and then I'm going to update each of the instances within the application class. So I'm just going to give the names of Melier, Bamford and Hernandez. And by running the application class again, we can see that the super keyword has been calling the player constructor, followed by the subclass constructor. I think with inheritance, constructors are quite a difficult topic, so it would be a good idea to play around with constructors to understand how they work with each other. So to conclude this tutorial on inheritance, I'm just going to demonstrate how subclasses are able to override the methods of the parent classes. And the first thing I'm going to do is create a void play method in the goalkeeper. And now what you will see is a red line. And the reason this is happening is because the subclass is trying to apply a default access modifier to the play method, whereas the parent class has a protected access modifier to the play method. And a rule with inheritance is that when you're overriding a method from the parent class, you're not allowed to apply a more restrictive access modifier to the method. So for example, if we had a public play method, you can't assign it to be protected, default or private in the subclass. If it was default in the parent class, you couldn't make it private in the subclass. So I'm just going to make this public, and I'm going to change the print line message. Now if I head back into the application class and call the play method of both the player and the goalkeeper, we'll be able to see the output in the console of the overridden method. So we have playing from the player, and then on the final line we have goalkeeper is playing from the subclass where it has been overridden. One final element of inheritance is that subclasses can also define their own methods without any restrictions on the access modifier that is applied. So for example, if I have a void method called save, the application class can call the save method, and we can see it being printed just like any other class to the console. And that summarises this tutorial on inheritance. I think inheritance can be a little bit complex, especially around the access modifiers and also the constructors. So it's a good idea to have a play around creating different classes and different extensions of classes to see how they work.